Good morning, Mars. So, in today's class, we will look at shorter methods for finding the asymptotes. The last classes, we have seen how to find oblique asymptotes, that is, asymptotes of the form y equal to mx plus c and x equal to my plus d. So, these are asymptotes which are not parallel to the x-axis and y-axis, so they are the oblique asymptotes. So, we'll be looking at shorter methods for finding these asymptotes compared to the previous method we have seen where we were finding these limits. So we were evaluating finding the asymptotes by using the limit, taking the limit of y by x and limit of y minus mx, and similarly x by y and x minus my. So instead of doing in that way, we look at shorter methods of finding the asymptote. So first of all, we will look at shorter methods of finding parallel asymptotes. Now, parallel asymptotes are asymptotes of the form x equal to k and y equal to c. So x equal to k, these are the asymptotes which are parallel to the y-axis, and y equal to c, they are the asymptotes parallel to the x-axis. So first we look at the shorter methods for determining the asymptotes of the form x equal to k or y equal to c. So we look at determining asymptotes parallel to coordinate axis. So first of all, let us look at the equation, how to find the equation of asymptotes parallel to the y-axis. So it will be in the form x equal to k. Now, if x equal to k is an asymptote, so when you take limit y tends to infinity. So as y approaches to infinity, the value of x must be approaching to k. Now we will be given a polynomial equation. നമുക്കൊരു asymptote കണ്ടുപിടിക്കാൻ ഒരു equation ഉണ്ടാവും. Now what we do is we will arrange the equation in the in the descending powers of 1. So for finding the asymptote, so arrange the given equation. Arrange the equation of the curve in descending powers of y. So our aim is to find what is this k value. Now since x equal to k is an asymptote, then you take limit y tends to infinity x. So this limit must be equal to k. So let us use this idea to find out the asymptote. For finding the asymptote, we are going to arrange our equation in the descending powers of y. So let me write the equation in the form y power m. അപ്പോൾ y power m ആണ് yയുടെ ഹയസ്റ്റ് പവർ വരുന്നത്. അതിൻ്റെ കൂടെ ഒരു എക്സിൻ്റെ കോഎഫിഷ്യൻ്റ് വരും. So let me write it as phi of x. Then the next power will be y power m minus 1 phi 1 of x. Y power m minus 2 is the next smallest power into phi 2 of x plus etc. Now here you divide by y power m. So dividing by y power m, so that will give phi of x plus 1 by y phi 1 of x plus 1 by y square phi 2 of x plus etc. equal to 0, and take limit as y tends to infinity. Now as y approaches to infinity, for 1 by y square, so on, they all tend to 0. And as y tends to infinity, നമുക്കറിയാം xന്റെ value k യിലേക്കാണ് approach ചെയ്യുന്നത്. So take y tends to infinity. So this is going to give phi of k equal to 0. So phi എന്ന് പറയുന്നത് നമ്മുടെ coefficient function. So here phi 1, phi 1, phi 2, etc. Are polynomials in x. And so phi of k equal to 0 will be a polynomial in x, where k is going to be the root of the equation phi x equal to 0. So solve for this polynomial equation. So we will get the roots k1, k2, etc. So these lines x equal to k1, x equal to k2, they are going to form the asymptotes of the given equation. So let k1, k2, etc. be the roots of phi of x equal to 0. Then the asymptotes parallel to y-axis are x equal to k1, x equal to k2, etc. So these are the required asymptotes. There can be cases where നമ്മൾ ഇത് ചെയ്യുമ്പോൾ നമ്മുടെ ഹയസ്റ്റ് ടേം, അതായത് ഹയസ്റ്റ് പവർ ഓഫ് വൈയുടെ കോഎഫിഷ്യന്റ് കോൺസ്റ്റന്റ് ആവാം. സോ phi of x can be constant, അല്ലെങ്കിൽ phi of x equal to 0 നമ്മൾ സോൾവ് ചെയ്യുമ്പോൾ the roots may not be real. But you can get imaginary roots when you solve for this equation. So in those cases where it is a constant or the roots are imaginary, in that case there will not be any asymptotes for the given equation. So that is a case where you do not have asymptotes parallel to the y-axis. So let us summarize what we have seen. So the asymptotes parallel to y-axis are obtained by equating to 0 the real linear factors in the coefficient of the highest power of y and the equation of the curve. And the curve will have no asymptote parallel to y-axis if coefficient of the highest power of y is constant, or if its linear factors are all imaginary. So when you solve for the equation phi of x equal to 0, if all the factors gives you imaginary roots, in that case there will be no asymptotes. And similarly, for finding the asymptotes parallel to the y-axis, so parallel to the x-axis, the procedure is same. Again arrange the polynomial. അപ്പോൾ നമുക്ക് വേണ്ട asymptotes എന്ന് പറയുന്നത് y equal to k ഫോമിലായിരിക്കും. അപ്പോൾ പോളിനോമിയലിനെ ഹയസ്റ്റ് ഡിഗ്രി ഇൻ എക്സിൽ എഴുതുക and then equate the coefficient of the highest power of x to 0, that will give the equation of the asymptotes parallel to the x-axis. So the asymptotes which are parallel to x-axis are obtained by equating to 0 the real linear factors in the coefficient of the highest power of x in the equation of the curve. So that's how we find the asymptotes parallel to the x-axis and parallel to the y-axis. So let us look at an example of finding the asymptote. To find the asymptote parallel to the coordinate axis of the curve, so the first curve is x square plus y square into x minus ay square. So we need to find the asymptotes parallel to the x-axis and y-axis. So first let us find the asymptote which is parallel to the y-axis. So y യുടെ highest powers lega. So that is y square into x minus a plus x cube equal to 0. So phi of x is going to be equal to x minus a. So upon equating x minus a to 0, we will get the asymptote as x equal to a. So the coefficient of highest power of y square is x minus a equal to 0. So that implies x equal to a is the asymptote. So the coefficient is x minus a. So upon equating that to 0, so x equal to a is the asymptote. Now we need to find the asymptote parallel to the x-axis. So when you take the coefficient of the highest power that is equal to a constant, then in this case we will not have an asymptote parallel to the x-axis. So the coefficient of highest power of x cube is 1, is constant. So therefore there is no asymptote parallel to x-axis. Problem is x square y square minus a square into x square plus y square equal to 0. So I have arranged the equation in decreasing powers of y and decreasing powers of x. So if you look at the first equation, the coefficient of highest power of y, that is y square is x square minus a square. So upon solving, we will get x equal to a and x equal to minus a. So those are the asymptotes which are parallel to the y-axis. Then upon arranging in the decreasing powers of x, so the coefficient of highest power of x, which is x square, it will be y square minus a square. So upon solving, we will get y equal to a and minus a. So those are the two asymptotes which are parallel to the x-axis. So this is how we find the asymptotes parallel to the x-axis.